Let's find the distance x across the lake. The figure is not to scale. What you can see here is I have a large triangle where x kind of goes across this piece of the lake, and we know this bottom distance is 115 feet. It is lined up with another triangle, and you can see this forms one line that goes through the hypotenuse of each of them, and this is 24 feet, and this is 18 feet. What we are going to do here is use similar triangles. Now, how do we know they're similar triangles? Well, we know they both have a right angle. And because this lines up, we know that these are vertical angles. So what do I know? I know that this angle is the same as this angle, and then the right angle is the same as the other right angle, which means that these last two angles have to be the same as well. So I know that corresponding angles are equal, which means that corresponding sides will have a constant ratio. So what we have to do is line up what corresponds to what, and what do we know? So what I'm going to look at is this 24 compares to the 115. I'm going to put the big one first. I'm going to say 115 compares to 24, so the big to the big, and I drop the units because they're the same and they would cancel, and that would be equal to, from the big triangle I have x, from the little triangle I have 18. Again, they should both be in feet. So what I want to do here is cross multiply. I'll have 115 times 18 will be equal to 24 times x. 115 times 18 is 2070. That's 24x. So my last step is to divide by 24. This says that x would be equal to 86.25 feet.